Hi, this is Vincent again, and we're going to go over some more complex numbers. So, in the last video, we talked about complex numbers, which was any number that contains the value of I. And we remember from our last definition, last class, was I is actually just shorthand for the number square root of -1. So, complex numbers. 5i, or 4i, is a complex number because it contains I. And remember, in our special case, we also said that numbers like this, 3i plus 7, is actually a complex number because this is as simplified as this value is going to get. In fact, numbers like 5 are completely real numbers, but can be expressed in a complex way. How? By adding 0 times I. This technically evaluates to 0, but this is a way to express this number, and it will become complex because it contains I. And so in general, a complex number is any number in the form ai plus b, where a and b are any number. As long as can be written in this form, then it's a complex number. So as you see here, this is 0i, so 0 is a, plus 5 is b. This just equals 5, which is a real number, but it can be expressed as a complex number. Similarly, here, 3 is a, and 7 is b. And here, 4i is just 4 is a, and 0 is b. So, now that we know how complex numbers are expressed, we know that this is the simplest form of a complex number. So this is the furthest you can go. So then let's give ourselves an example. Let's suppose that the value p is equal to -1 plus 5i. And let's say some other value q is equal to 3i. What is the value of something like p squared times q? Well, let's just start by putting the numbers in. So we know that p is -1 plus 5i. So we'll just write that. -1 plus 5i squared. And we know that q is just 3i. So let's write that too. Times 3i. And I don't know if you guys seen this notation, but this just means multiply. I like to use dot more than like cross. Anyways, so let's just start with our order of operations. First things first is parentheses, but this is as simplified as we can get because remember it's in the form 5 is a and -1 is b. So this is as simplified as we can do so far. Next is exponents. So we need to square this. So it's actually I plus 5i times I, or -1 plus 5i, and then all times 3i. So then let's start here. How are we going to multiply these together? Well, let's just use the FOIL method that we've learned about before. So to FOIL, you go, or FOIL, you want to go first. So -1 times -1, which is 1, plus outer. So the outermost are -1 and 5i. So -1 times 5i is -5i. Inner, well, this is the same thing. So it's -5i. And then last. So 5i times 5i, which is plus 25, because that's 5 squared, and then I squared. times 3i. So we can simplify here. We get negative 10i plus 25i squared. But remember what we talked about in last class? We said that I is just a shorthand for the square root of negative 1. And so if we square the square root of negative 1, we actually get negative 1. So what we're actually getting is 25 times negative 1. And then obviously we can just multiply those together to get negative 25. And then times 3i. So from here, we can continue to treat I as a variable, only trying to simplify when we have to, like in this case right here. So an easy shorthand to remember is you can always try to simplify once you get something like this, and you can know to simplify i's when they get powered up like this. But other than that, you don't need to simplify because they'll just act as normal variables. So let's just continue with this example. Let's move over here. So we need to multiply this 3i into this entire equation. So the distributive of a property is our friend here. So we'll do 3i times 1. That's just 3i. Then we have 3i times negative 10i. So that's negative 30. Because those are the two numbers that are getting multiplied, and then the i's get multiplied, so we get negative 30i squared. And then here we have 3 times negative 25, which is negative 75. And don't forget the I, because we're also multiplying by I. So negative 75i. Remember, this is a power of I, therefore it can get simplified. So it's minus 30, and specifically for I squared, we remember that since I is the square root of negative 1, the square of I is just negative 1. And then we subtract by 7i. So now we're left with 30 times negative 30 times negative 1 is 30. And let me write it over here, 30. So these are like terms. So we can actually combine them. So 3 minus 75, well, that'll give us a negative number. And what is that negative number? Well, it would be negative 72. And another way to think about it is flip this, like pretend this is like what you're subtracting by, and subtract this number by this, but just keep the negative sign. So that's how I did it. So, like 5 minus 3 is 2, but I just keep the negative sign. But that's just like a small shorthand thing you can think of. And so we remember that complex numbers are in the form of AI plus B, and we have our A right here. It's negative 72, and we have our B, which is 30. And now we know that this is as simplified as we can get. We have a real number minus a complex number, or actually what you could say is we have this complex number, which is negative, plus the real number, or it would be plus negative 72. And so we know that this is completely simplified because it's our definition of a complex number. Let's go over some more examples. So let's say we have 6 plus 5zi, where z is just some variable that we have, times 1 plus 3i minus 6 plus 5, or actually it's 6 minus 5zi times 1 plus 3i. This is our example. Whoa, that looks really complicated, doesn't it? It's really long, but don't get too overwhelmed. Let's start and take it slowly, and we're going to break it into smaller parts. So the first thing to do here is we want to, so let's start by maybe making this easier for ourselves. This is a really long problem, but let's pretend that these were just like maybe, let's say that this was x, and maybe this is just any number, like a normal number, just pretend. Notice how this term is similar to this term. So if they're both the same, isn't there some kind of rule that we can do to maybe, I don't know, move them out so that we don't have to think about it? There is. It's called the distributive property. So let's simplify. We want to make our lives easier, not harder. So let's try to take this out of the entire equation. The distributive property means we're going to divide both of these by this number to be multiplied in later. And so what we'll be left with is 6 plus 5zi minus 6 minus 5zi. Now that looks a little bit cleaner, but let's see if we can make it even more. This can get smaller. How? By just adding the terms. So what does it mean when a minus sign is outside of her parentheses? It means that you're multiplying everything by -1. And so what you can do is you can say this times -1 times 6 is -6. And then here, -1 times -5zi is equal to positive 5zi. And here is our distributive term that we got to distribute out. Obviously, we can cancel out the 6's, because 6 minus 6 is 0, and we're left with 10zi. So let's continue. 1 plus 3i times 10zi. So let's distribute back in. 1 times 10zi is just 10zi. Let's see. 3 times 10zi. Let's multiply the parts that are, since when you multiply, you just multiply all of it together, we can start by parts. So 3 times 10 is 30. Z times, well, there isn't another z term, so we'll just multiply it by z. And then finally, we have I times I squared. And then remember, I has a square. What do we do when I has a square or is to another power? We recall the 4 I powers. I to the 1 is equal to I to the 2 is equal to -1, I to the 3 is equal to -I, and I to the 4 is equal to 1. This one we've already solved before, because if you remember the definition of I, it's the square root of -1. So the square of a square root is itself, and so we get 10zi plus, plus 30zi I squared is -1, -1. And multiplying that in, that actually just makes this -30z. And you'll see that this z term is really just another thing that can be put into A and B. So we actually have A is 10zi, or I don't need to write this, but you can see the A in this complex number is 10zi, and then the B part is just negative 30z. And so we turned this really complicated problem into its much simpler form. And we didn't need to panic because all we needed to do was break it into chunks. Just try to find the patterns and try to make your life as easy as possible.
So to cover one last example of this complex stuff that our friend Vince has introduced us to, there's Vince. Let's try what happens whenever you have square roots and you need to square a complex number. So let's have radical 5 over 5 plus radical 3 over 2i. And we want to square that. So what do? I wrote that big. So this is just that number multiplied by itself. So we've got radical 5 over 5 plus radical 3 over 2i times itself here. And let's try that mnemonic that we were using before, the FOIL. So to do that, we're going to take the first term and find their product. With a fraction, you can if you're multiplying fractions, you can multiply across the numerators and across the denominators and get the fraction out at the end that way. So we have radical 5 times radical 5, which when you square a square root, you just get the number under it. So you get 5 divided by 5 times 5, which is 25. And then after that, we've got plus outer, so radical 5 over 5 times radical 3 over 2i. In the same way, we can just multiply these radicands together, which are the things under the radical, giving us root 15 divided by denominator product, which is 10. We still have an I in the end here, though. And conveniently, since we're squaring, we can just get 2 of those because the inner is going to be the same as the outer. So radical 3 times radical 5 over 2 times 5 with the I there. So instead of saying plus that again, I'm just going to go ahead and plus 2 of them. And finally, let's square the last thing. So we've got plus radical 3 times radical 3, so that's 3 divided by 2 times 2, so that's 4. Then I times I, which is I squared. But as we learned last time, I squared can wrap around to become a negative, so that the I squared kind of dissolves into a negative sign. So now we have 5 over 25, which really, if we do a little bit of division, is 5 over 5 times 5, which is 1/5, minus 3/4, plus all this nice juicy I stuff. So we can go ahead and put that over on this side of the board and get 1/5 minus 3/4 plus, and we have a 2 and a divided by 10 right here, so what we can really do is just divide by 5 because the 2 will cancel with the denominator. So plus 1/5, and then we have that square root of 15 that we can't really do much with. Square root of 15i. So now the last thing that we can do to simplify is going to be to combine these real values, the 1/5 and the 3/4, into a common denominator, which is going to be 4 of these minus 5 times 3 of these, so 4 over 20 minus 15 over 20 equals negative 11 over 20. So I'm going to move up just a step here to kind of do the final solution of the problem here. We've got minus 11 over 20 to replace those, plus radical 15 over 5 times I. And that is our solution whenever we square radical 5 over 5 plus radical 3 over 2 times I.
And we know that this is simplified because if you remember our definition for complex numbers, this is b, this is the real part, and radical 15 over 5 is a.
And that concludes our introduction to complex numbers this week.
It's not as complex as you thought it was.
Oh my gosh. You're killing it, guys.